So in this session, we're going to talk a little bit about using CredHub with Kubernetes. I'm Peter Blum. I work at Pivotal. I'm a platform architect. So I work with a lot of our customers. Specifically, I've been working as of late with our PKS customers. And I've seen a lot of instances where they're looking for a great credential management system. So I thought this talk would be a great idea. And I have with me Eugene. You want to introduce yourself?
Hello, everybody. I'm Eugene. I'm from Belarusian branch of Altoros, working with Cloud Foundry. So let's begin. It's security. It's complicated and serious topic. So this serious guy will be with us, helping us to understand what's wrong with Kubernetes, how to deal with credentials, and how CredHub can help us with this. Actually, everybody has secrets, and application also. Databases, messaging queues, internal services, external APIs. Your mobile phone has a PIN code. Your Wi-Fi router has a key, or probably not only one. And even your TV set nowadays has a password. So credentials is essential nowadays. Kubernetes itself is not an exclusion. It's a platform, and it's having a lot of key secrets, all such data, as well as applications which are running inside the platform. If you want to use some single container, simple application, even here you should think and should consider about credentials to avoid some botnet using your container. Kubernetes has a wonderful API object called secrets. Who can imagine? It enables developers not to place secrets in manifest, exclude them, and manage them separately. It's quite an old thing, well documented, so it's ready to use. It helps developers to use 12-factor application pattern that they love to get credentials as environment variables into their containers. Secrets in Kubernetes are base 64 encoded, and secrets are stored at etcd along with all other Kubernetes objects. When we are using secrets, we can describe deployment with kubectl, and we can see only the links to the credentials, not the credentials itself. But this approach has some issues which I'll describe later, so you can stay with us. And now I want to speak a bit more about credentials itself and things connected with it. It's a complicated stuff, credentials, and it has quite a lot of issues. Configuring credentials, it's hard. We can remember Equifax having admin as their password. Or I can remember probably Wi-Fi router with also default credentials, which ordinary user can forget to change. Also, detecting credentials leaks is also hard. Security breaches can exist for years, and bad guys using them, and nobody can notice. The one's neighbor, for example, can use this Wi-Fi password with admin for reading news, and it's probably not the worst thing that can happen. The only thing which is simple about credential is leaking them. Just one single git push, and your password or your AWS credentials are in public repository, and everybody in the world can see them. Not probably the best thing when somebody is mining Bitcoin in your AWS account when you are sleeping. So CredHub is here, like Chip or Dale, ready to help. It's a tool to generate, encrypt, rotate, and audit credentials. It's simplifying configuring credentials, making leaking credentials a bit more difficult, and detecting credentials leaks is also good with CredHub because it has some auditing system, but it's not silver bullet. So for detecting credentials leaks, some other approaches and tools would be used. CredHub is stateless, so it's scalable, reliable. It can demand all your needs. It supports HSM if it's necessary for you. It's 100% free, having no gold or professional or other paid version. All things is here out of the box. And it has a real granular access control. All custom security policies like this user should access this secret, and this user can delete and write that secret, but not that. Everything can be configured simply. CredHub has several credentials type, actually many of them, and I can't imagine the stuff that is not here. Passwords, keys, certificates, everything is there. But it also has some custom JSON types. Once I've seen the proof of concept where guys using CredHub as config server using these JSON primitives. It's probably not the best thing, but it's reliable, has a simple IP, so why not? The main credential deployment type is Bosch release. It's available on GitHub, and actually it's the only supported one. If you need CredHub near your Kubernetes installation, you just get Bosch release, install it, and can use CredHub with CLI or REST API client or anything. You'll have all the Bosch magic with you, like self-healing or multi-cloud, or Bosch is wonderful. In SpringOne, you know it. When we started our development, we wanted something not so heavy as Bosch. It's wonderful, but we wanted something that allow us to fast deploy, delete, run several versions in parallel. So in the other words, we need something that platforms like Cloud Foundry or Kubernetes can provide. So we ask ourselves, can we just deploy CredHub to Kubernetes and use its power? Actually, we can, using Helm. Helm is a package manager for Kubernetes, something like PIP for Python or NPM for Node.js. The Helm unit is a chart. Chart is something, how to install application, how to upgrade application. It's a set of YAML templates, so any good YAML programmer can do the job. It's fast, simple. It uses full representation of Kubernetes API because it uses the same logic as kubectl create or something like this. And it uses huge existing library of application charts, and if you want to rely on something, you can just use this chart. They are production ready, actually. In our CredHub chart architecture, we relied on UA as a source of identity and on PostgreSQL database as a backend for storing credentials. Actually, what is important here is that we wanted to use secrets, which I described below. Kubernetes secrets are nice, but when we started to use it, we understand base 64, it's not encryption. Not every single Kubernetes installer has encryption enabled by default. And even it has, when master VMs are compromised, secrets are exposed. It's not something the best we wanted to have. But again, we are in SpringOne, we know a lot about Cloud Foundry, and if we are using pivotal application services open source, Cloud Foundry, CredHub is already with you. It's inside, you can just use it. So we decided to stop on this and use this existing CredHub. We wanted something completely different, some tool that can allow us to get credentials from CredHub securely without etcd, and then push it into the container where the code can use it without going to CredHub API and using it. So Peter will describe how we can reach it.
Awesome, thanks. So now that we know a little bit about CredHub and Kubernetes, how do we integrate with them? Well, there's really two planes of integration. How about generating credentials and getting those credentials into CredHub, and then actually injecting those credentials on runtime? So as developers, we're pretty much spoiled with our experience on PaaS. With PaaS, we have the Diego launcher, which is open source Cloud Foundry component, that really takes our CredHub parameters and automatically interpolates them and puts our secret into the running application. So that as a developer, I never even have to know that there's CredHub behind the scenes. And that enables a whole bunch of great stuff that Scott Frederick and I will talk about in our talk at 5 o'clock today, so make sure you come. But you know, I wanted to get that same experience on Kubernetes. So generating credentials, let's start on that side. The goal here was to create a secured secret. So instead of just a secret, I wanted to create a new type in Kubernetes that was a secured secret type. So I could use that. If you're familiar with custom resource definitions in Kubernetes, I wanted to make my own custom resource definition. And so I actually did. And so I created a custom resource definition called secured secret, big surprise. And that actually worked great. But now, once I have that custom resource definition, how do I actually take that and send it to CredHub? And how do I log into CredHub to store that secret? And how do I set the actual permissions on that secret? Well, there's a few different ways of doing that in Kubernetes. With CoreOS, they brought to the table something called the operator API. The operator, if you were at the earlier talk where they talked about Kafka, they're talking about Helm charts and operators. So that all came from CoreOS, and we started to look at that. And that was a great little framework built around Kubernetes, and it was great, worked. But what I ended up finding was after I created an operator, before my operator gets those secured secrets, they're stored in etcd. So it didn't really end up helping me. I spent about a week creating that operator, and it didn't even work for what I wanted. So then I took a look at the API extension. API extension is really a component of that operator API, so it's one single component inside that operator. And that itself, once again, stored its components and its types, in our case, a secured secret, inside of etcd. Kube Builder took another look at that one. That one is really a whole automation around building those API extension servers. So it's another great project. Took a look at that. Again, secrets are stored in etcd. And finally, if you're at all familiar with PaaS or service brokers, I took a look at the service catalog. The service catalog itself is really the way to use open service brokers with Kubernetes. So if you don't know already, but CredHub has a service broker that works with CredHub. So great, I thought I could plug it right into the service catalog and then go ahead and use that. Well, once again, I was let down. Why? Because those credentials before being passed to the service broker are stored in etcd. And that's really one of the key concepts that I learned the hard way that Kubernetes does not allow us to do, is anytime you create a resource, it's always going to be placed in etcd, no matter what you do, no matter how hard you try. And the real reason is because all of these extensions are, they're implementing the Kubernetes base API. And at the base of the API is every single object gets stored in etcd. And that way, you have one data source for Kubernetes. You only have to deal with one data source. And in my case, I'm trying to actually pull those objects out and store them in CredHub. So unfortunately, I never was able to get this goal. So while I can't store those credentials via kubectl, creating an object or something similar to that, you can use the CredHub CLI. And I'll show you a little bit later. And of course, something that we talked about doing, if we never got to, was actually creating a kubectl plugin. So you can actually create a plugin that would shell out to CredHub itself. So great, we couldn't get that done, but I was still determined to get something working to show at my SpringOne demo. So what was I gonna do? Well, I said, well, you know, on PaaS we have this great experience of pulling credentials in from CredHub as a developer, and I never even know that it's there. I want that experience on Kubernetes. So how can we get that to work? Well, we got that to work with a mutating admission webhook, a custom Kubernetes controller, and init containers. And so I'll kind of bring you through those. Hold on tight. This is like a supremely deep conversation about core Kubernetes components. So if you don't know what a webhook is, or what a controller is, or what a master is, or what a X509 certificate is, just go look it up after the talk and come back and watch this again. So let's pretend that we have a Kubernetes cluster out there, and we have our master out there, and we have the CredHub service deployed. This could be either with the Helm chart we spoke about earlier on Kubernetes, or it could be on a VM deployed by Bosch. Really up to you. And so we've got these two things out there, and as a developer, I'm going to go ahead and use the use the CredHub CLI to store a secret inside of CredHub. And then what I'm going to do is I'm going to do a deployment to Kubernetes. So I take and I do my normal YAML deployment. We all love YAML if we're working with Kubernetes, so we do our YAML deployment, and we send that off to Kubernetes using the kubectl. Now, what's really important is that on our YAML, on our deployment, we have an annotation called credhub.pivotal.io. And what we notice is with our webhook, we notice that, hey, there's this annotation on the deployment. That means they want to pull credentials in from CredHub. Awesome. All right, so in order to do that, I've got to now add to that deployment an initialization container and a volume. Why? Well, because I need to use the initialization container to pull those credentials in from CredHub, and then I'm going to store them on a volume that my containers inside my pod that I requested can actually go ahead and access, right? So let me walk you through a little bit about this. So the webhook really goes ahead and alters my deployment, adding this initialization container and this volume to my deployment. From there, once my whole pod is coming up, I have a controller, a Kubernetes controller. Now, everything you do in Kubernetes, deployments, pods, they're all responsible and maintained by controllers. In my case, I have a CredHub controller. And so the CredHub controller sees that a new initialization container has come up, and it's a CredHub type. Great. So the controller says, well, I'm going to go generate a certificate, an X509 certificate, so I can transfer credentials to that container via MTLS. Remember, CredHub supports MTLS and OAuth 2. So I go ahead and I create that certificate. Notice here, the certificate is only valid for the namespace SpringOne. That's a key component here. Why? Because that's where my pod is running. It's running in that namespace, and we'll get into that in a little bit. So once I get that certificate, the controller then sends that certificate over HTTPS to our initialization container. Our initialization container then uses that certificate to pull in whatever credentials he actually has access to. And then finally, he stores those secrets into the secrets volume. And as a last step, we kill that initialization container. So if you followed that whole workflow, which it's hard to follow, I know. It's a complicated process. It took me a long time to learn as well. I'm going to actually demo it. So hold on tight. Let's give this a try. All right, so what we're going to first take a look at is, let's go ahead and take a look at our Kubernetes CredHub namespace and see what's out there. Currently, I have a pod, and it has 2 containers inside of it. So what are those containers, you might say? That will look perfect. So we can take a look, and what we see is we should see our webhook. So our webhook is running for us, and our our controller is running for us. So these would be expected, if I were just using a cluster, right? My platform team would deploy me a Kubernetes cluster, and inside that cluster, before I go to use it, I would already have these containers running, right? And so what I'm going to go ahead and do now is I'm going to show you what a deployment looks like. So we're going to actually do a deployment and try to get secrets out of CredHub. But beforehand, let's go ahead and generate a new credential. So I'm already logged into my CredHub instance, so I'm going to generate a new password. But in this case, I'm going to generate it with Kubernetes CredHub /credentials / my namespace. So in this case, I have a SpringOne namespace. Now that's very important, and I'll talk about that in a second. And in this one, I'm going to call it demo1, and I'll make it a password type. So why is it important that I specify the path like this? Well, it's important because I'm going to create a certificate for you that only has access to Kubernetes CredHub credentials and then your namespace. So if your namespace is Peter, and I'm trying to access Eugene's namespace, I can't access it. I'm not going to get a cert for his namespace. I'm going to get one for my namespace. So it's very important that you store your credentials with that proper syntax. So once I go ahead and I do that, now I'm going to go ahead and, well, I can just show you that it actually created. So if we do CredHub get -n, and we just do the same thing. Now, everybody's going to see my secret, so don't copy it or anything. Shouldn't do that, but there you go. It was created. Awesome. So I really wanted to get that. That was my first use case, right? I wasn't able to get that into Kubernetes, but hey, we've got the CredHub CLI. Let's go ahead and use it. Now what we're going to do is we're going to try to get that credential into my container without ever having to pass it in as a Kubernetes secret or as an environment variable, right? So I'm going to create a deployment. Let's make this a little bit bigger. Okay, perfect. So I'm going to create a deployment. Inside that deployment, I'm going to have a container. It's a very simple container. You'll love it because it's got our dog on it. It's a really cute app. But what's really important here is it has the CredHub Pivotal IO annotation. This is key. If you don't have this, you won't get those credentials. This is the on-off flag, if you will, for getting those credentials from CredHub. So great. We're going to go ahead and deploy this. In case you're interested, we're going to be able to access our application over a node port. We'll figure that out later. So let's go ahead and do a deploy. So we're going to go ahead and do a deployment. And we're going to get immediately, I'm going to go ahead and get the status of the deployment. There's a reason for that. I'm really slow at typing, and so if I were to wait, I wouldn't see that initialization container actually being spun up. So here you can see that I have an initialization container being spun up for me. But you might say, well, I never specified that in my deployment, so why am I getting an initialization container? Well, remember, we had that webhook listening to see if I have that annotation, right? And if I do, then I'm going to now get an initialization container and I'm going to get a volume. So let's go ahead and get my pod now and see what actually it looks like after it's been created. So if we take a look at this, so now what you'll see is I don't just have a container anymore. I have an init container as well as a container. So I didn't ever request this, but I got one. And I also have a volume here that I never requested as well. And I also have on my container that I did request, I have a mount path. Wonder where that all came from. Well, it came from that mutating webhook that we talked about earlier. All right, so now that we have that all running, let's go ahead and understand, well, what is being stored in that secrets volume for me? Well, what's actually being stored is my secrets. How did it get those secrets? Well, let's go ahead and take a look at the logs. So let's pull down, I gotta get my, So if we take a look at this, and now what I'm going to look at is I'm going to look at that initialization containers logs. Why? Well, I want to show you what actually happened here. Kubernetes, CredHub. I should have made these names shorter. God. Hopefully no typos. Nope. Okay. What? Oh, I know why. It's the wrong one. Okay. There we go. Hang on. We're just going to grab our logs. All right, great. So these are our initialization container logs. So what you can see here is our initialization container came up. It had two endpoints. It had a v1 health and it had a v1 receive credentials endpoint. So what ended up happening is our controller sent an X509 cert to our initialization container. And you can see it received that cert here. And then what it did was it went out and it curled CredHub, and it actually logged in with that MTLS using that X509 certificate, and it listed the credentials in my namespace. Now notice it's only the ones in my namespace. So here's the one that we just had created, demo 1. And so what you can see is that for each credential it finds in that namespace, it actually goes out and gets that credential itself. So now let's go ahead and actually see what credentials we actually got. So I got to get my node port. And let's see, what was it? It was 35, yeah. So if we come in here, we grab our node port, we put that in, and look at this. This is our application, and our application is very simple. Let me show you what the application does. So the application is just a very simple Go app that just goes ahead and reads the credential folder, and it, example app, main.go. So all it does, oh, that's a little too big. All it does is it reads our CredHub volume, and it just prints out whatever files are on there. So what you can see is that it actually goes ahead and prints out our credentials. So here is our password that we had created beforehand. And so as a developer using Kubernetes, all I have to do is add an annotation to my pod, and I immediately pull all the credentials I'm allowed to access out of CredHub and into my container, and I never have to know about CredHub. I don't know how to log in. I don't know how to set up my client. I don't have to set up any client-side libraries in my container. I never have to worry about it at all. It's all done natively for me. And so I wanted to just close with letting you guys know that it's all out here on GitHub, and you guys are more than welcome to use it. We have a nice little deployments bash script that deploys all your Kubernetes objects for you, creates the certificates that you need for this. We also have our Helm chart out here, and we have our example application because you know you want one of those dogs in your applications. And we have our containers. So we have our controller container, our webhook container, and our initialization container out there as well. And finally, we would love any and all help to put this together. So any pull requests are more than welcome. And I think that's where we're going to end up, right? Perfect. Cool. So I think we have a little bit more time. I know that was quite a run through, but are there any questions? Sure.
So what happens if you were able to change the credential,
Yeah. So if you wanted to do that, you could just like you do with. So if we go ahead and do a CredHub. So do you want to go ahead and delete the existing credential and then create a new one with the same name? So if we do CredHub, delete -n. Let's see if I can find it on here, the one that we were using. Oh no, you guys see all my credentials. Let's delete that one. Let's create a new one. So we'll generate the same one all over again. So now in our application, unfortunately, we have to rerun our init container, right? So the only way that we can rerun our init container is we're going to have to kubectl delete, right? So we have to delete that pod. Yeah, it's just like with CF, right? You're still in Cloud Foundry, you have to go ahead and restage. And Kubernetes, unfortunately, it's on a hook. When we see that new deployment coming up, we can't edit an existing deployment. So, yeah. Sure, in the back. Sure. So the question was, is there any way to transfer credentials from Vault to CredHub? Yeah. Sure. Yeah, so I'm not super familiar with the backing store for CredHub. For Vault. So I don't know what the backing store for Vault's. It possibly could be many. But if you could actually share the backing store between, so CredHub itself and, I don't know how Vault works, but CredHub itself is really just a microservice that lives on top of a data source that integrates with, with an HSM or just, plain old encryption. So it, you can just, point the database. I don't know what Vault uses, but if you can use like a database, CredHub just ends up storing all of its credentials inside of a database. So if you, and then you could pass the encryption key over to Vault, and Vault should be able to decrypt those entries in the database, and you should be okay. Besides that, I can always use my good old friend Concourse to create a pipeline that does some logging into, CredHub and pulling it up. Yeah. They're really different tools for different purposes, right? So Vault is really I wouldn't say is as integratable, right? So there's always a key that has to be passed around with Vault to log in, right? With CredHub, in this case, there is no key that I have to pass to my container. When you're on, Pivotal Application Services, you're just getting a new cert laid down for you on the container that gives you access to your credentials. In this case, I don't really need to give my application any master password or a key to get into, right? That's all done for me by the platform. So, yeah. Anything you want to add to that one? No?
So
All right.
for me.
Cool. All right. Thanks, guys.